This is a quick video I made about temperature feedback system I built because I lost the thermostat to my house when I was remodeling it. Oh yeah, I got a house. It's a bang bang control system, controls the thermostat in my house. That's interesting. It works all right. I tried to build a transformer for the power supply. I fail. I end up using a simple USB power supply. For 4 months it runs fine, and then I finally finished it off with a good display. Hope you like it.
Geez, Bennett, looks like where you had your thermostat, there's only 2 wires sticking out of the wall now. That's right. We're just gonna make a new thermostat. Wait, this video is about a thermostat, not breakfast. Wait, what? Hold on. This is what I call an upkeep and maintenance project. I have to periodically make things because it keeps my brain working. You know, I might learn something. It's actually the most powerful way to learn anything. Is just go and make stuff. Very excited. So I'll have to go find a transformer. And if I want to make it really nice, I'll put a solid state voltage regulator after the buck converter, which is actually a good way to build power supplies. So then you get the precision with the efficiency of the buck boost converter. I worked for a company, they built power supplies for the military. Cool. Yeah, this project I was thinking it would take like an hour, but now I'm talking about it and I've realized this is not smart. So smarter. Right, USB, phone charger, 5 volts. It was the first project with a MOSFET I used, which is pretty cool. And then I used these little temp sensors, which I'm going to use again. So this is why we record stuff. I don't remember how to use them. This project was like 6 months ago, but I sure have code that I wrote 6 months ago that should just work. Save you the time of figuring it out. So let's see what we got. Here's the relays, which will control the heat in the house. Close this little temp sensor here. Alright, so here we have it secured on the wall. We have this relay right here hooked up to the 2 control wires, both to the bottom there. I heard it. Just turned on the furnace. I hear it downstairs.
Some time has passed. I used that thermostat I built for probably like 4 months. I finally basically finished it, I think, because the old one didn't have any display like this. See, we have 2 numbers, and one is the set point, and the other is the reading from the temp sensor on the bottom. And if we, there you go to the threshold. Now, this turns on when it's calling for heat from the thermostat, and it's shorting together these 2 wires right here. So you just connect these 2 to the house heat, and there's a pot. I couldn't find a button, so I had a buzzer that I put through a full bridge rectifier and made a peak detector. It goes from 45 to 85. Right. So here's the temp it's measuring. Here's our selection. Turn it up. Say. Yeah, and the heat just turned on. You see this dropped by 7 because of the hysteresis, and I could have put the program in to not do that, but meh. Cool. Here's our code. This stuff is to use the 4-digit 7-segment displays. It's I think the 4th one down. Here's our stuff. So 6 is the tap input button. 10's our indication LED. 3's the house heat. I can take this out so we can talk with the computer. Okay, so basically all of the code's in a while loop, which pulses in and out every 150 milliseconds. And then I tried not to use delays, but they're really simple and easy. But okay, so this is all a while loop. So we pulse this while loop every 150 milliseconds. And then while we're in the while loop, I mean, the first one, there's actually 2. We check our densitometer. So we're like, what temperature do we want? What temperature is the sensor saying? What's our tap sensor doing? And now that we know all that, we can decide whether or not we should turn the heat on. So if our desired temperature is less than if our desired temperature is less or equal to our target temperature, we turn the heat on. If let's say it's not, so we'll skip through this whole wall loop here, and then we'll come down here, and this just keeps the house heat off, and then down here we output to our display. If we go into the wall loop, I think it's the same as it was before. So say we turn the heat on, so we step inside, turn the heat on, turn on our LED, check the sensor temperature, introduce a 7-degree hysteresis bump so it can't flicker on and off. So essentially the house has to heat 7 degrees past your target temp before it turns off, and this is because I don't want it pulsing on and off all the time. And then we're going to check our desired temperature, and we're going to output to the display. The first 2 digits are your desired temperature, the second 2 digits are your measured temperature. This was a really easy display, and then here we output all the numbers. Because they're integers, you can just divide them down and it just cuts off the bottom 10. So, say, our desired temperature was 56. We take 56 and we divide it by 10, and that gives us just 5. And then D1 is 5, because 5 is the tens place. And then D2, we come back here and we say, okay, give me our desired temperature, but subtract down D1, which is now 50, times 10. So if it were 55, we get 50 out to D1, and then here we have 55 minus 5, which turns into just 5. So we get 55, and that's how it works for both displays. There's other ways to do it, but this was the most simple. This is one of the most simple little displayer things I've done so far. And then we have a 150 millisecond delay. And if this is statement still true, we go back through and we just sit in here until we basically go 7 degrees above. Then we step out. So yeah, it's very simple. I love it. Let's go put it on.
Hope you guys like that. If you made it to the end, hero. Not all heroes wear capes. Have a great day.